Uh, Good day, ladies and gentlemen. Analytical geometry is whereby the geometric problems are solved using the Cartesian planes, right? We know what is a Cartesian plane, right? A Cartesian plane Cartesian plane is something that looks like this, so whereby you have your horizontal axis and your vertical axis or y-axis or x-axis. This is a Cartesian plane. So what they are saying to us is that analytical geometry, in analytical geometry, we are solving problems based on the system, Cartesian plane. And furthermore, let's say you have length, you have midpoint, you have length, you have midpoint, and gradient. Let's say you have length, midpoint, gradient, then the coordinates or points can be found. If you have one of these, then we can determine the coordinates of points. For example, let's say you have a midpoint. You have the midpoint. Midpoint means you have 2 points. Then you can just determine the midpoint of those 2 points, whereby you can get your points or coordinates of that point. Okay. Other concepts. The concepts will be, you need to understand that you have circles, you have distances, you have midpoint, you have straight line, and you have gradient. Right, you need to understand this. You have circles. In this Cartesian plane, you have circles, you have distances, you have midpoints, you have straight lines, you have gradient. There's a lot of concepts that you need to understand. Okay, you also have your non-vertical lines. Non-vertical lines, right? You know a line that looks like this. Your y-axis is your vertical. This is your vertical line, a line that is horizontally straight like this, it's a vertical. A line that is vertically straight is a vertical line, like straight. And then your horizontal is any line that does not look like this. That line is non-vertical. That non-vertical line, we say, for example, let's say you have a line that looks like this, or like this, or even like this. Let's say if A and B is parallel to BC. For instance, let's say this is A, this is B, right? B. Again, let's say this is B, this is C. Ne? If AB is parallel to BC, then the gradient of AB is equal to the gradient of BC. Also, if, let's say this is your lines, this is A, this is B, then we have another line, B, we have C, right? If AB is perpendicular to BC, like AB is perpendicular to BC, then the gradient of AB multiplied by the gradient of BC must be equal to -1. Lastly, let's say you have a line that looks like this, and then you have A, you have B, you have C. You have 3 points, 1, 2, 3. You have 3 points on the same line. If A, B, and C are collinear, then the gradient of A, B is equal to the gradient of BC, which is equal to the gradient of AC, vice versa.